Hello everyone. Education is the most powerful weapon which can use to change the world. In this quote, today I am going to take a topic in the subject CS 3551 Distributed Computing Message Passing Systems versus Shared Memory Systems. I am Ramya, Assistant Professor, Department of Information Technology, Nanda College of Technology, Erode. First one, message passing systems. Two processes communicate each other only passing by messages. Message passing has two types. The first one is direct communication. So one person can directly communicate with other person, so that is direct communication. So our two processes can communicate with directly each other, so that is direct communication. So another one is indirect communication. So indirect communication means example of message box we have to send one message to the some person, so that receive that message to the another person, so that is indirect communication. Next one, message passing systems requires synchronization and communication between two processes. Message passing is used method of communication in microkernels. Messages sent by a process has many forms. The first one is fixed size, that another one is variable size. So you have to send some messages to that one particular person or some other persons. So that is fixed message. So we have to add another some points to that person, means that is variable size. So size are variable, so that is variable size message. Then message passing primitives, we have two message passing primitives. The first one is send primitive. So that send primitive means that message is going to reach that destination name. So what we are going to reach, that is a message. So send messages to the destination is send primitive. So that another primitive is receive primitive. So where we get that message, so we have to get that message from source name, and that what we going to get, so that is message. So receive messages from that source, so that is receive primitive. We have two primitives, that first one is send primitive and that other one is receive primitive. So the next one is shared memory systems. So shared memory systems, common shared address space is used for throughout the system. Communication among processes are shared data variables and control variables. Processes can exchange information about reading and writing data to the shared region. Shared memory allows maximum speed to communicate between two processes. So next we are going to see what is the difference between message passing systems and shared memory systems. The first one is message passing systems. Platforms that exchange messaging for sharing data are called message passing systems. Here, shared memory systems. Platforms that provide a shared memory for data sharing are called microprocessors. The second difference for message passing is, here we are going to sharing small amounts of data. In the shared memory, processes of sharing data are not writing same location simultaneously, so that locations we are going to change that. So that is shared memory systems. The third difference for message passing systems is faster communication, and that third difference between shared memory system is slower communication. So the next one, message passing model, processes communicate with other for exchange of messages, that is message passing systems. And the shared memory systems, we have that shared memory model, processes communicate and data to share create a shared memory region. So message passing technique can be used heterogeneous computers. In the shared memory techniques, we are not going to use heterogeneous computers. So this is the difference between message passing systems and shared memory systems diagram. So in that message passing systems, we have to use one memory, that one memory followed by one process, and that one memory, one process communicate with interconnection networks. Like that memory 2 and then memory 2 followed by process 2 that communicate with interconnection network up to memory n and a process n that interconnected with interconnection network. This is message passing system. In the shared memory system, we have to allot it in the center of the interconnection network. So in the interconnection network, we have to both sides we have to use that process 1 and that memory 1. In both sides we have to use like that process 2 and memory 2 up to process Pn and M1 that are interconnected with that interconnection networks. So this is the diagram of message passing systems and shared memory systems. So the next one is emulating message passing systems on a shared memory systems. Shared address space is divided into two disjoint parts. Sender and receiver operations are implemented by using writing and reading information from receiver and sender process. Here we are using PI and PJ. That PI and PJ message passing can be emulated by a write by PI to the mailbox and read by PJ from the mailbox. So we have to use two operations, one write and read operation. So one is write by PI, another one is read by PJ. So this is the today's topic. So today's we are going to learn about that message passing systems. What is message passing systems and what is shared memory systems? What are the difference between message passing systems and shared memory systems? So these are the topics today we are going to learn. See you soon. Thank you.